Alright, so what we're going to talk about is convection current. It's a definition. You can see the top says a circulation pattern, that's an N, in which material is heated and rises in one area, then cools and sinks in another area, flowing in a loop. There's two things you need to understand. One, warm, less dense fluids rise, cold, more dense fluids sink. So you got to think about this in terms of the gizmos that we worked on. And we saw that when we put objects into water, which has a density of 1 gram per milliliter, if the density is greater than 1 gram per milliliter, it will sink. If it is greater than 1 gram per milliliter, it will rise. So what we need to think about here, we were given a beaker, right? And we took the temperature of that beaker, and let's say the temperature was 22 degrees Celsius. Yours might have been different in the lab, but that's fine. But that's the temperature of the water inside there. Then what we did is we placed an ice cube. Let's see if we can get a different color in here. Put an ice cube up here, our dyed ice cube, right? Which is cold. So we placed that cold dyed ice cube in here, and what we saw was that the dye kind of melted out and sank to the bottom. And what you might have noticed is that when it hits the bottom, it kind of pushed outward. So this is cold, dense, sinks. Then what happens, as it goes through the water, it actually heats up. So then it starts to go upward. Warm, less dense, rises. So the reason why it gets warm is that this cold air inside of here, or cold water inside of here, actually heats up the cold dense fluid. So then it rises. As it rises and gets to the top, it then comes in contact with the ice cube. And if I have warm fluid coming in contact with the ice cube, it's then going to get cold again, and it's going to sink. So notice that this is what we call a convection current, because it goes around. We'll get some fancy things. Got a lightsaber here. So what we have here is cold sinks. It's heated up by the surrounding fluid. It then rises, hits the ice cube, gets cold again, and sinks. So eventually what you ended up with in the experiment was a beaker that became a uniform color of both the dye. So this is just me coloring this in, right? So that circular pattern is like if we took a spoon and we stirred it. Now, in the other, so that was just fresh water. In the other part of the experiment, we put the ice cube again at the top, but this time we had salt water, which, if you go back to our gizmo, that the density of it, of salt water, is greater. And if you remember the guy floating in the Dead Sea, so what happened was there became a barrier, right? And what happens is salt water is more dense, fresh water is less dense. So the less dense sits on the top, while there's a barrier of more dense more dense liquid. The convection current still happens at the top of here. This is a bird's eye view of the top, looking down. If you think about it, say our ice cube was on the side here, we can still say that the cold fluid sinks, but it's just traveling around. And as it travels around through the salt water, which is warmer, it warms up until it hits the ice cube, then it cools down, and then in the water it warms up. And this is why you ended up with, say, a temperature at the top of, say, 12 degrees Celsius. So this is at the top. And then down here would say 14 degrees Celsius. Again, fresh water is less dense, so it sits on top. You didn't have this convection because of this barrier. Watch the video again if you need explanations for it.